Hello, accelerated chemistry students. This is Ms. Crystal Foley, and this is your Chapter 9, Section 3 video notes all over naming and writing formulas for molecular compounds. I know that ionic compounds were a little confusing. That's why we spent a couple days on it in class, but molecular compounds are a lot easier. So let's go through these. So you know that a formula for a binary molecular compound is going to be written, and then you can write the name or write the formula or vice versa. So molecular compounds, remember, are composed of two elements, but they're both nonmetals. So we're not going to have any ions in this. They're all going to be nonmetals. So how do we do this? We're going to name the least electronegative element first. And we're going to add prefixes to indicate the number of atoms. So the first thing you want to do is look at the prefixes on the bottom. I'd write them all down in your notebook. So mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. And what we're going to want to do is we're going to want to make sure that we understand that we do not write mono on the first element. It's only written on the second element in these formulas. So we're going to write the first syllable of the second element and then add IDE at the end. So the first element is written normal. Second element, you write the first syllable of it, and then you end IDE on the end. So let's look at an example. What is the name of CCl4? Well, C stands for carbon, so we're going to write that first. And there's 4 chlorines, so we're going to write tetra, which is going to represent the 4. And then we're going to change chlorine to chloride. So carbon tetrachloride. Let's look at another example. So what about this one? So we have N2, so that's di, because there's 2, nitrogen. And then the next part is going to be oxide, and there's mono, oxide. So dinitrogen monoxide is how we're going to write that. When you have 2 vowels next to each other, you're going to drop the double vowel, and we're going to get more practice with that as we go through some more examples. Let's look at another example. So SF6. So S is sulfur. There's 1 of them, but remember, we don't write mono on the first one. Hexa is the prefix for 6. And then fluoride. Remember, spelling does count in this chapter, so make sure that you are spelling these things correctly. All right, so what about N2S5? Well, we have 2 nitrogen, so that's dinitrogen. And then we have 5 sulfur, so that's pentasulfide. It's not too bad. It's a lot different than ionic, but it'll be okay. We're going to do lots of practice. So what if we're writing the name of the formula? Instead of writing the chemical formula, what if we're writing the names? So prefixes, remember, are the number of atoms of each element, and they're indicated by the subscripts. So write down the element symbol in the order of the name with the appropriate subscript behind it. So let's do an example. So what is the formula for dinitrogen pentoxide? So the first element is nitrogen, and that's a 2. And then oxide is O, and there's a 5 after it. So N2O5 is dinitrogen pentoxide. Let's look at another example. So what is the formula for carbon monoxide? There's 1 carbon, because remember, we don't write mono in front of the first element. So there's 1 carbon and 1 oxygen. So that's going to be CO. And then what is the formula for carbon dioxide? Again, we don't write mono in front of the first element. Writing the element symbol as it is represents that there is one there. So we have 1 carbon in this case. We have 2 oxygens in this, so we're going to write CO2. And let's look at the last. What is the formula for phosphorus trihydride? There's no prefix in front of phosphorus, so we know that there's a 1 phosphorus in this formula. And trihydride is 3 hydrogens, so PH3. And that's how you name molecular compounds. Pretty straightforward and easy. The only thing I could suggest for you is to make sure that you know all of your prefixes. And that is the end. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbooks, resources, CD, and pearsonchem.com. Thank you so much.